Hello everyone, I hope you all are doing good. In this video, we would be learning matrices. So before we move on, we need to first learn a few things about matrices. The first thing is, what is a dimension of a matrix? A dimension of a matrix is given as row by column. So these are the 3 rows in this one, and these are the 2 columns in this. So there are 3 rows and there are 2 columns, which means that we can write this as a matrix having a dimension of 3 by 2. What is a square matrix? A square matrix is written as a matrix that is written as A, B, C, D, which means a matrix that has a dimension of 2 by 2. Now, what is an identity matrix? Identity matrix is given as a capital I, which is 1, 0, 0, 1. Now let's move on to the solving of matrices. First thing we have is addition and subtraction of matrices. These two are dealt in the same way. Let's do a question. So we are adding 1, 2, 3 minus 1, and we are adding 2, 3, 4, 6. Let's add them together. So whenever you're adding, first of all, you have to make sure that the dimensions are same. If not, then that question will not be possible. So let's start. 1 plus 2 is 3. 2 plus 4 is 6. 3 plus 3 is 6 again. Minus 1 plus 6 is 5. So this is my final answer. Okay, let's do a question of subtraction as well. All right, let's take this dimension. 0, 1, minus 2, 3, 6, 8, subtracted by 1, minus 4, 6, minus 7, 8, and 10. All right, let's simplify this. So 0 minus 1 is a minus 1. Then 1 minus 7. If you want, you can always write this down in a working column. So this would be 1 minus 7, which is 1 plus 7, which is written as 8. So we will be writing 8 as our answer. Okay, the next thing we have is minus 2 minus 4, which means minus 2 plus 4, which is 2. 3 minus 8, which is a minus 5. Then 6 minus 6, which is a 0. And 8 minus 10, which is a negative 2. So this is our final answer. Okay, what about this matrix? Tell me what would be the answer of this one. So we have this matrix here. Okay, let's write it down. 1, 2, 3, 4, 5, 6 added with this one 2, 2, 1, 6. Can you add them? No, we cannot, because the dimensions of the matrix are not same. This is 3 by 2 and this is 2 by 2, which means that they cannot be added together. All right, let's move on to multiplication of matrices with a number. This is very simple. Okay, so we have a matrix here and I'm multiplying it with a 2. 1, 2, 3, 0, minus 1, 6. Let's multiply it. This would be 2, 4, 6. 0 times 2 is 0, 2 times minus 1 is minus 2, and 2 times 6 is a 12. Simple multiplication. How about this question? 1 over 3 multiplied by 4, 6, 9, 0. Let's multiply them. So this would be 4 over 3, 6 over 3, 9 over 3, and 0 over 3. Can we simplify this further? Yes, we can. So let's simplify this. This would become 4 over 3 cannot be simplified. 6 over 3 is a 2, 9 over 3 is a 3, and 0 over 3 is a 0. So there you go. This is your final answer. Okay, now let's move on to comparing matrices. Comparing matrices is very simple again. So first of all, you can see that you have to find the value of k. Now there are 2 ways of doing this question. Either you can expand both and then you can equate it and then simplify it, or what you can do is just pick it. So if we have to find this, that means I'm interested in this value over here. Let's expand this. So 3 by 2 is going to give me a 6. 2 by k is going to give me 2k. So what is the value of k? The value of k is 3. Simple. There you go. All right, now let's move on to the multiplication of matrices. Multiplication of matrices is where you have to definitely look at the dimension. So this matrix over here is 2 by 2 and 2 by 2, which means that it's going to give me a 2 by 2 matrix again. So let me write it down so that you know what I'm talking about. 2 by 2 matrix. 2 by 2 matrix. Whenever you're multiplying matrix with a matrix, you have to first check whether the last one and the first one over here are same. If they are same, only then you can proceed with it. Otherwise, you cannot. And now I have to make sure, I have to check what am I forming. So I am forming this matrix here. This is the proper way of doing it. So you first check whether these two are correct, whether these two are the same, whether they match, and then you have to check what matrix would you be forming. So 2 by 2 matrix is a square matrix again. Now, how do we multiply it? First, let me highlight it. This is the first row and this is the first column. I will be multiplying them. Okay, and when I multiply them, I would be forming this over here, this value over here. After that, I will multiply the first row and the second column, and I would be forming this over here. What is this? How do you define it? This is the first row and the second column. Then I will be multiplying the second row and the first column, which would be this value over here. So let me just mark it. And in the end, the second row and the second column, which would be this over here. If you still did not understand this, just look at these values. This is the first row, first column, first row, second column, second row, first column, and second row, second column. All right, now let's start multiplying them. Okay, so I will multiply 2 and minus 1, which will give me a minus 2. 6 and 0, which will give me a 0, so plus 0. Then we have this and this. So 2 by 3 is going to give me a 6. 6 by 1 is going to give me a plus 6. Okay, then we have the second row and the first column. So 4 and minus 1 will give me minus 4. And 8 and 0 is going to give me a 0 again. All right, the last one now. So last row, last column, 4 by 3 gives me a 12. And 8 by 1 gives me a plus 8. So there you go. Okay, let's simplify this. My answer will be minus 2, minus 4, 12, and 20. So this is my final answer. All right, let's move on to a different one. So the dimensions here are, this is a 3 by 2 matrix and this is a 2 by 3 matrix. First, let's check, are these two same? Yes, they are. And what will we be forming? We will be forming this over here, which is 3 by 3. Okay, 3 by 3 matrix means the first row and the first columns, let's multiply them. We would be getting 1 times 0 is a 0, 2 times 4 is a plus 8. Then we have the first row again and the second column, which is 1 times 5 is 5 and 2 times 3 is a 6, so a plus 6. Then we have the first row and the third column. So 1 times 1 is 1, 2 times minus 2 is minus 4. The second row, first column, 1 times 0 is a 0, 0 times 4 is also a 0. Second row, third column, minus 1 times 5 is minus 5, 0 times 3 is 0. Then we have the third one. So minus 1 times 1 is minus 1. 0 times minus 2 is 0 again. All right, this and this. So 6 times 0 is 0. 4 times 3 is 12. This and the third one. So we have second one. 6 times 5 is 30. 3 times 3 is 9. All right. 6 and 3, 1 and minus 2. So 6 times 1 is 1. 3 times minus 2 is minus 6. So let's simplify them now. This is my answer and I'm going to simplify them. This will be 0 plus 8 is 8. 0 plus 0 is 0. 0 plus 12 is 12. 5 plus 6 is 11. Minus 5 plus 0 is minus 5. 30 plus 9 is 39. 1 minus 4 is minus 3. Minus 1 plus 0 is minus 1. 6 minus 6 is a 0. There you go. Just quickly check. Is this a 3 by 3 matrix? Yes, it is. Isn't this what we were supposed to form? Great. So your work is perfectly done unless you've made any calculation error. Okay, let's look at the last one here. The last one here has a matrix of, this is 1 by 3 and this over here is 3 by 2. Okay, the last ones are same again. What am I going to form? I will be forming 1 by 2. All right, so let's start multiplying them. This will be multiplied with this to get 4 times 0 is 4, minus 2 times minus 4, minus 2 is minus 4, 6 times 1 is a 6. Okay, then I have to multiply the first row again and the second column. So 4 times 3 is a 12, 2 times 7 is 14, and 6 times minus 1 is minus 6. That's it. There's no other row. So let's simplify this. This will be 4 plus 4 is 4 minus 4 is 0 plus 6 is 6. 12 plus 14 is 28. 28 minus 6 is 22. So this is your final answer. You can check it. 1 by 2 and again 1 by 2. 1 row and 2 columns. Okay. Now let's move on to the inverse of matrices. Inverse of matrices has a formula. The formula is, it's only applied in a square matrix. So let's suppose this matrix here, A, B, C, D. Let's name this matrix. This is matrix A. I want to find the inverse of this matrix. So the inverse will be written as 1 over the determinant of A. A determinant, a mod means basically that you would be canceling out all the negative signs if there is any, multiplied by the matrix. Now just see how I'm writing it. I'm changing their positions. A and D will become DA, and I'm changing the signs of B and C. So this would become minus B and minus C. Okay, what is a determinant? Determinant is basically, I'm writing down the formula here. So determinant has a formula as well. This is AD, which is this, multiply them, and then minus BC, which means multiply them. Okay, let's take a question here. Question is 1, 2, minus 4, and 6. Okay. So I have to find the inverse of this. Let's say this is matrix P. I have to find the inverse of P. So inverse of P will be 1 over determinant of P multiplied by changing of positions, which means DA minus B minus C. Let's first find the determinant. The determinant would be AD minus BC. So AD, which is 1 times 6, I'm finding the determinant. Let me write it down. So AD minus BC, 1 times 6 minus B is 2 and C is minus 4. Let's simplify this. This will be 1 times 6 is 6, minus minus is a plus, 2 times 4 is 8. So 6 plus 8 is 14. This is my determinant. Okay, now let's form the matrix. The matrix would be, P inverse is 1 over 14 multiplied by changing the positions. This will become 6 and 1. Changing the signs, this will become minus 2 and a plus 4. You can simplify this further. This can be written as 6 over 14. 6 over 14. Okay, let me write it again. 6 over 14 minus 2 over 14. 4 over 14 and 1 over 14. Okay, I can simplify this further. So this can be written as 6 over 14 can be simplified to 3 over 7 minus 1 over 7, 2 over 7 and 1 over 14. So this is your final answer. Okay, I hope this was clear, and if not, please feel free to ask me and I will be there to help you. Thank you very much.